Organochromium chemistry is a branch of organometallic chemistry that deals with organic compounds containing a chromium to carbon bond and the reactions. The field is of some relevance to organic synthesis. The relevant oxidation states for chromium range from -2 to +6. History. The first organochromium compound was described in 1919 by Franz Hein. He treated phenyl magnesium bromide with chromium 3 chloride to give a new product. After hydrolysis, which he incorrectly identified as pentaphenyl chromium bromide, pH5CrBr. Years later, in 1957 H. Zeiss et al. Repeated Hein's experiments and correctly arrived at a cationic biserine chromium sandwich compound, R2Cr+, bis, benzene. Chromium itself was discovered around the same time in 1956 by Ernst Otto Fischer by reaction of chromium 3 chloride, benzene and aluminum chloride. The related compound chromazine was discovered a few years earlier in 1953 also by Fischer. In another development, Annette and Leblanc also in 1957 prepared a benzyl chromium solution from benzyl bromide and chromium 2 perchlorate. This reaction involves one electron oxidative addition of the carbon-bromine bond, a process which was shown by Cauchy to be a case of double single electron transfer, first to give the benzyl free radical and then to the benzyl anion. G. Wilker et al. Introduced tris-eta-allyl chromium in 1963 as an early Ziegler-Natta catalyst, but not successful in the long run. Chromazine compounds were first employed in ethylene polymerization in 1972 by Union Carbide and continue to be used today in the industrial production of high-density polyethylene. The organochromium compound, phenylmethoxycarbene, pentacarbonyl chromium, pH, OCH3, C = Cr, CO. 5 was the first carbene complex to be crystallographically characterized by Fischer in 1967, now called the Fischer carbene. The first ever carbine, this one also containing chromium, made its debut in 1973. The first example of a proposed metal-metal quintuple bond is found in a compound of the type Krath-2, where R is a bulky aryl ligand. Applications in organic synthesis. Although organochromium chemistry is heavily employed in industrial catalysis, relatively few reagents have been developed for applications in organic synthesis. Two are the Nozaki-Hayama-Kishi reaction, 1977, transmetallation with organonickel intermediate, and the Takeo olefenation, 1986, oxidation of Cr2 to Cr3, while replacing halogens. In a niche exploit, certain tricarbonyl RNA chromium complexes display benzylic activation. Organochromium compounds. Organochromium compounds can be divided into these broad compound classes. Sandwich compounds. Chromazines CP2Cr and bis. Benzene. Chromium derivatives. ARH, 2Cr. More commonly studied are half-sandwich complexes like ARH, Cr, CO, 3. Chromium carbenes, R1, R2, C, CrLn and carbines, R, CrLn. Chromium, 3. Complexes are CrL5, ethylene polymerization and oligomerization. Chromium catalysts are important in ethylene polymerization. The Phillips catalyst is prepared by impregnating chromium Vi oxide on silica followed activation in dry air at high temperatures. The bright yellow catalyst becomes reduced by the ethylene to afford a probable Cr2 species that is catalytically active. A related catalytic systems developed by Union Carbide and DSM are also based on silica with chromazine and other chromium complexes. How these catalysts work is unclear. One model system describes it as coordination polymerization. With two THF ligands the catalyst is stable, but in dichloromethane one ligand is lost to form a 13-electron chromium intermediate. This enables side-on addition of an ethylene unit, and a polymer chain can grow by migratory insertion. Chromium compounds also catalyze the trimerization of ethylene to produce the monomer 1-hexene. Comparisons with heavier group 6 organometallics. The heavier group 6 elements molybdenum and tungsten form organometallic compounds similar to those for chromium but also with differences. Whereas Cr3 acroalkyl compounds are well studied. The corresponding Mo3 and W3 compounds are not, whereas chromazine is a stable compound. The related molybdenacene and tungstenacene are highly reactive. On the other hand, Mo and W readily form derivatives of the type CP2MX2, whereas the smaller Cr does not form such clamshell compounds. Homoleptic alkyl and aryl complexes of the type R4M are rare, and hexamethyl tungsten has no analog in Cr chemistry. Similar are the carbonyls such as molybdenum hexacarbonyl and tungsten hexacarbonyl and the related carbene and carbyne complexes. Compounds of the type CPM, CO3, 2 are known for all three metals, e.g. cyclopentadienyl molybdenum tricarbonyl dimer. The chromium compound is however prone to hemolysis of the Cr-Cr bond owing to steric crowding. In the Kaufmann olefination, molybdenum 3 chloride and methyllithium form an organometallic complex capable of carbonyl olefination. See also other bonds of carbon with elements in the periodic table.